Um, Good morning, everybody. Welcome to the second day of EuroPython, this 2013 edition. We are here with Kerstiens, who will show us the latest addition to the Postgres database. Craig, the show is yours. Thank you.
Hi, everyone. So for just some really quick background on myself, I work at Heroku. For those that aren't aware, Heroku, we're a platform as a service. We've been doing it for a while, mostly in the Ruby space and then Python for the past 2 years or so. Specifically, I work as a product manager on the Heroku Postgres team. And we run the largest fleet of Postgres databases in the world. So we know a little bit about running Postgres, configuring it, and then kind of what's inside so you can take advantage of it. So digging in a little bit, actually first, one shameless plug. If you're on a Mac, which it looks like most people are, give postgres.app a look if you haven't already. If you're trying to set it up locally, don't worry about Mac ports or Homebrew. This is just like a native drag and drop installer that just works, just like you'd expect on a Mac. The other one, Postgres Weekly. It's a weekly newsletter I curate, just a few links every week with good content, good blog posts, and that kind of thing. All right, so a little bit of what we'll kind of dig into today. First, I'm going to give you a little bit of history on Postgres, not too much there. Then dig into when you're developing with it and designing with it and working with it, what to look for performance, and then a little bit on querying and reporting and just some nifty tricks around that. So really first, it's Postgres or PostgreSQL. It's not PostgreSQL. It's not PostgreSQL. This is actually the biggest contributor to Postgres today. He helped create TIFF, JPEG, PNG, and is now probably 50% of the code in every Postgres release. And this is an email he sent to the list about 10 years ago that the naming is arguably the biggest mistake they've ever made. And he actually was in the office about a week ago and still stands by this and was actually hopeful that we might be able to revisit it. But basically, it's Postgres or PostgreSQL. So it's been around since about 20 years, depending on how you look at it, whether it was SQL or before SQL. It comes out of Berkeley, the same roots of Oracle and DB2 and most major databases. And one really important thing is it's completely community-owned and community-driven, meaning you can't have a company come in and buy it and change the license and do other things with it, not to mention the other databases by name. One important thing is MVCC. So this is multi-version concurrency control. This is kind of at the root of everything under Postgres. What it means is essentially you can write data and read data at the same time. When you're reading data, you see what was written and committed at the time that you're reading from it. So you don't have to worry about writing, locking a table and not being able to read from it. So this is actually a quote from a coworker, and I'm actually not an Emacs user myself. But I think what he means here is it's more of a data platform. It's really flexible. You can do a lot on it. It's not just a relational database. It's more about a storage engine, a fast executor, query planner, all these things which kind of make it useful to you. Really, it's pretty flexible, which we'll dive into. All right, so on developing with Postgres. The very first thing is pSQL is your friend. Most people, when they come to Postgres, they look for some kind of GUI editor or tool like that. pSQL really is quite great. Let's blow that up a little bit more. So I can just pSQL into a database. I can describe my tables pretty clearly there. I can run a basic query. I can actually, let's see. This is a really handy thing. \x auto will auto format the output for me. So this up here looks pretty nasty. If I rerun this exact same query, it's going to put it in a much more legible form right off for me. But if I actually put it something like just email, it's going to put it, in a multi-line or a single-line form like that. One thing that probably everyone wants to do is set up their default editor inside your terminal, and that when you do that, you can do \E in Postgres and edit the query in whatever you want. I can edit it right here in Vim, change it a little bit, save, and run it again, which makes it a lot more handy than having to deal with typing right into the command line. You can set it up for Sublime Text or whatever your editor is, which is nice. So a little bit on data types. Postgres takes a bit of a different approach than most databases. It doesn't take the approach that you have to have 5 or 6 data types and push things into that. You can essentially be quite flexible with it. You've got like 6 numeric types. You've got IP and MAC address. You've got basic shapes. So this isn't even talking about GIS stuff. This is just really basic shapes. So you've got things like polygons and points, and you can actually compute the distance between those inside the database pretty natively. One particular one that I really like that I think is way underused in applications. Well, actually, it's used commonly inside code, but not inside your database, is arrays. So inside Postgres, I can create an array of any other data type. So in the case when you're doing something like categories, if you've got a basic blog application or a shopping cart, and you want to tag things with categories, there's no reason you should have to join this to another table. So I can do it like that, and then from there I can insert strings directly in there. Another really handy one that came in Postgres 9.2 is range types. So if you're building a calendaring application, this is probably what you want. Normally you would have 2 different columns. You would have a from and a to column. This puts it all inside the same column, so you can actually enforce constraints. So you would just create a time range, put your times in there. You can actually do it so that it's greater than or equal to and then less than this time there. Basically, the brackets and parentheses have that value there. Yeah. Yeah, so that's actually intentional. So the bracket on this side.
Can you repeat the question on the microphone? Sorry.
Yeah, so I think the question was essentially, is that a syntax error right there with the parentheses and the brackets on the other side? So the bracket means it's, and I could have this reversed, but the bracket means that it's this time or greater, and this means it's less than this time. So it's actually a kind of a form of expressing what you mean to do inside it. So if it was a bracket, it would actually change the meaning of it on this side. So the really nice thing with this is that you can start to put constraints down in your database. So if you've got a university scheduling application and you open up scheduling and everyone tries to register for the same class, you're going to go and check and see if you've got the class is full. Or in the case of the pie barbecue, you're going to keep checking inside the database, but never restricting one. But you're going to check if it's full. Then you're going to say it's not. OK, then someone can write. But you could actually have 2 people try to write at the same time, and the database isn't going to know how to handle this. So with a really basic constraint here, this can actually say, we can't have 2 people talking in the same room at the same time. So you've got your database enforcing constraints the same as your application. So beyond the basic types in Postgres, Postgres has support for something called extensions. These are a weird middle ground. There's some that already ship with Postgres. You just have to turn them on. There's others that don't ship with Postgres, but you can download and install. These are the ones that ship natively with Postgres. So they're already there. You can already use them. You just have to basically turn them on. Related to data types, there's a few key ones. There's HStore, case-insensitive text. There's a cube. And one of those that we use a lot actually at Heroku inside some core systems. We find a lot of people, once they discover it, really like it, is HStore. It's basically a key value store inside your database. So I can create it right here. Then I can just insert key value directly into that column. So if I hop over here onto my database, I can see right here on data, I've got key for sex as female and state as Washington. The nice thing about HStore is you can add index on it the same way you would any other column, and I can actually filter on that. So I can say where the sex is equal to female and get that back. Or I can filter for male the same way. Get something entirely different back. So you can index on it. You can query on it. You can do whatever you like. The big limitation of it really, though, is that it's a key value and it's only strings. You can't do anything else with it. So it is a little limiting. But that's where JSON starts to come in. So in Postgres 9.2, it got JSON support. It's also a little limited. So you can put JSON data in. It'll validate it. But it's not necessarily as performant. So there's trade-offs right now between HStore and JSON. But as soon as you start to add something like PLv8, so PLv8 is the full V8 JavaScript engine embedded inside the Postgres. So that's the same engine that's in Chrome, that's in MongoDB, right inside Postgres. So you can do something like this. Does anyone have any idea what this is doing quickly? So this is executing any arbitrary JavaScript code I'm sending into my database. So this isn't necessarily a good idea. But you can actually do some really powerful things. So it has support for CoffeeScript. So you could actually run CoffeeScript tests inside your database where it's close to your data. You can index on JavaScript. And this one's actually a little more interesting. So you could do something like this. Create an index on zip codes. And then you can filter based on the zip code, where that's actually inside some JavaScript document. So PLv8 makes it much, much more powerful. And it's definitely, if you're a JavaScript person at all, kind of worth looking at and using, or if you're working with JSON documents in Postgres. There's also full text search built in, so you don't need to use Solr or Lucene if you're looking for something basic. And even then, it's actually pretty performant. So you can go a long way with the Postgres full text search out of the box. And then if you're doing geospatial stuff, PostGIS, it could have a full hour on it by itself. If you're doing location-based apps, geospatial stuff, PostGIS, and in particular with GeoDjango, it just works pretty well out of the box. All right, so a little bit on performance. Sequential scans, when you see this on your database, it's typically bad, but that's most of the time. That's not all of the time. I wouldn't say try to avoid them all the time. If you're doing batch jobs or large reporting, then it's pretty okay most of the time. Indexes, of course, are good, but also most of the time. There's not a perfect always use one or the other, and Postgres is usually smart and going to do the right thing. So on indexing, Postgres has 5 types of indexes right now. It has a B tree, a gen, gist, k nearest neighbor, and sp gist. If you're like me, the first time you saw this, it looks something like this. It's really not too bad. Most of the time, you don't have to think about it. You can just say create index. When you just say create index on some column, it's going to use a B tree. This is what most other databases have. This is a pretty common index type. And this is what you usually want. You usually don't have to think too much about it. Gen index you want to use when you have multiple values in one column. So this is the case when you're using HStore and array typically. Not always the case. Sometimes gist will be more performant. But usually you can use a gen and it'll work just like you would expect. And then gist. Basic rule of thumb here is for full text search, geospatial, anything kind of where you're dealing with basically those. Full text search has a few other operators as well, but typically just indexes are the most common one here. On the other ones, KNN. KNN is for similarity, how similar are two things. And SPGIST, I still don't understand after having it explained to me like 20 times. I hear it's good for phone numbers. So if you're building an application with phone numbers, maybe it's what you want to use. So beyond that, how do you take a query and optimize it? Given a really basic query like this, how do you actually tell if it's doing what it's supposed to, if it's slow, if it's fast? Postgres has something called an explain plan. So you can take this and, actually I don't think I have this query in my database, but I can run explain on any query and it'll show me what it thinks it's going to do and how long it thinks it's going to take. So in this case, it's going to run a sequential scan on employees. And you can see right there, it's going to have the startup time, which you can mostly ignore, you don't have to worry about. A few dots, and then the max time. The max time is actually one of the more important ones, as well as the rows returned. So there we can see that's a pretty big max time. That's 35,000 milliseconds, so 35 seconds it thinks it's going to take. And then how many rows it's going to return. It thinks it's going to return 1. If you take that and add explain analyze instead, it's going to give you two things. It's going to give you the explain output, what it thought it was going to do, but then it's also going to run the query and tell you what it actually did. So now we can actually pay attention to what our startup time actually was, how long it actually took to do that specific operation, how many rows were returned, and the total actual time. So in this case, I can see that my actual time is 295 milliseconds. For some really rough rule of thumb, if you're building a web application, these rules apply there. If you're building another type of application, if you're building a reporting application or something entirely different, throw this out the window and find your own recommended guidelines. But for most web applications, rare queries should be under 100 milliseconds. Common queries should be under 10 milliseconds. And I'll actually typically aim for around 1 millisecond on my really common queries. So obviously, given that the actual time here is pretty bad if this is a common one, even if this is a rare one. So given it's doing a filter on salary, what I would do is this. I would create my index on salary, and you can see that it's going to then use an index scan like you'd expect, and take that runtime down from 295 milliseconds to 1.7 milliseconds. So this is right in the ballpark that I would expect a query to perform. A few tips on indexing. Create index concurrently. If you haven't heard about this, you've really been missing out. If there's Django users in the room, you can't use it with a south migration because it runs inside a transaction. Create an index concurrently. What it's going to do is create your index in the background. So usually when you run create index, it's going to hold a lock on the table so you can't write new data. This is the case today with MySQL. I'm not sure on the state of SQL Server or Oracle. I believe Oracle has an equivalent to create index concurrently. But create index concurrently is basically going to create your index in the background. It's going to be 2 to 3 times slower, and then just start using it right away. So you can keep writing data without having to bring down production to add an index. Conditional indexes are great. So you can create an index where some condition is true. A good example of this is if you're writing a phone book application, and you've lived at 20 addresses, you don't care about all the old addresses, you may want to save that data. But now I can index where my current address is true. So I'm indexing only 5% of my data instead of all of it. This is generally bad. If you have a wildcard at the beginning of your query, there's no index that can optimize for this. This is actually pretty okay. If you start with something that's actually a string and then have the wildcard at the end, you can actually take advantage of your index. With extensions, there's a few extensions for getting more insight into your database. In particular, the PG row locks and stat tuples give you information there. You can dig in on those. And that's great, but how do you know that your database is doing well from like the 30,000 foot view? Like, how do you know it's okay without looking at every single query that's being run? Again, for web applications, there's a couple of key metrics that I think every person running on Postgres should pay attention to. The first is your cache hit ratio. So Postgres by default is going to keep frequently accessed data in memory. And basically, serving from memory is a lot faster than serving from disk, as you would expect. The other thing is your index hit rate. This is how many times is it using an index versus not. That last query will give you something that looks roughly like this. It'll show you how often the index was used on a specific table and how many rows are in the table. Rough guidelines for this, I would say your cache hit, you want it to be at 99% or higher. The slides are all online, and I'll make sure they're connected to EuroPython site as well. But essentially, cache hit 99%, run that query, and it'll give you a percentage. For index hit, about 95%. If you can do 99%, that's great. If you're low on your cache hit rate, add more memory to the box or upgrade boxes. If you're low on your index hit rate, try adding more indexes. And then indexes generally on anything greater than 10,000 rows. You can do smaller tables, but a lot of the time, it's not necessarily worth the cost. And so one other really, really awesome extension is PG stat statements. PG stat statements is going to normalize every single query that's run against your database. What this means is when I actually run a query where I have my email address in there instead of that question mark, I'm actually saying where it's craig@heroku.com. It's going to replace that constant for that question mark. And this is going to track how many times this query is run, how long it's taking on average and cumulative, and all of these things about how many shared blocks, how many blocks are dirtied, all that sort of thing. So you can basically see across your entire system, what's the most expensive query on your database, and then start to optimize that. So yeah, this query will basically give you that. Let's see if this will work for me locally. And I don't have it turned on locally. But this will give you basically your total your query name, or the full breakdown of your query, and then the total time. So you can basically start at the top of the list and start picking them off. It'll look something like this. Some other things. If you're on Heroku, there's something called Heroku PG Extras. It's a plugin for the command line. If you're not on Heroku, just crack open the source and look. It's got the queries for cache hit, for index hit rate, for locks, for sequential scans, all these things that make it a good bit easier for you. All right, so on to querying a little bit. First, window functions. Window functions are probably one of the most confusing things in Postgres to actually explain. But when you need them and once you start to realize what they are, they become incredibly handy. So I'm actually just going to run this query and try to walk through it that way. So what I've got right here is, if I describe my tables, I've got products and purchases and users. And this query shows me the spender and their rank by state. So what I'm doing there is grouping by state, but then ordering inside that on state. So if you can see here, I've got New York, I've got 1, 2, 3, 4, 5, 6, 7. So basically, you've got some subgrouping on something you want to group on. And you could filter out where rank is equal to 1. So if I wanted to find the top spender in every single state, I wouldn't have to create a cursor. I wouldn't have to pull this out in Python or Ruby. I can just do it directly in my database. It's really great for things like cohort analysis and that kind of thing as well. There's also, of course, a variety of extensions around reporting. A really fun one is fuzzy string matching. If you wanted to, just a really lightweight spell check of sorts, I can run this and see that the SoundX rating and the difference between Craig and Will, the difference is 1, which is actually the greatest, and then the least is 4. So I can say, do Craig and Greg sound similar? And you've got a difference of 3 here. And you can tell their SoundXs are pretty similar. I actually don't know what the SoundX rating is. I assume it's something kind of from that field, but you can easily dig into it. It's just kind of a fun one. A little more practical, moving data around. if you're doing batch loading or bulk loading of data, don't do a bunch of inserts, use copy. It's efficient, it'll parallelize loading the data. You can copy and basically send any query you want in there. You can export it to CSV, to tab separated, any kind of file format you want, and then import from that pretty well easily as well. One other nice thing though is if you don't want to deal with throwing CSVs around and you've got a lot of Postgres databases in your company and you want to have them talk to each other, you can actually use something called DB-link. So DB-link, I can query from one Postgres to another and join across that data. So basically, I would create a connection to this remote Postgres and then execute queries against it. And it's not limited to just Postgres. So the overarching mechanism for this is something called a foreign data wrapper. It hopefully does what it sounds like in that it'll wrap some external source. There's ones for MySQL, Oracle, Twitter, though I don't actually know what the Twitter one does or why you would want it. MongoDB, Redis. So there's really quite a variety. There's more and more coming out, I think, every few weeks. To set it up, looks something like this. You only have to do this once. You basically say, enable the extension, tell it where the server is, and then define your tables. So if I go back over here locally, I do /d, it'll show me everything in my database. You can see I have this Redis DB right here, and it's actually called out as a foreign table. So I can query from it. And I actually got my Redis server running locally. So I just actually queried Redis from inside Postgres. So then you can think of interesting use cases such as this. In this case, I've got Redis that's tracking all of my user visits. And basically, every time a new user visits, I increment Redis. So I can, with this query, I have to do a little bit of casting because Redis isn't too great on the types right now. But basically say, anytime they're greater than 40, and then join against that and giving me their email. So I could say, my users that browse my site a lot, if I want to send them a coupon or something like that, I could easily do this. And of course, you could do it with other databases as well. So Mongo, MySQL, basically anything you want just about. Another nice thing for readability is common table expressions. Who here likes writing SQL? Okay. Who here likes reading SQL? Okay, if anyone put their hand up on that, that would have been awful. SQL is a really powerful language. It can do a lot, but it's not usually a very pretty one. Common table expressions or with clauses make it a lot better. I'll commonly find myself writing now like 80-line SQL queries that are actually readable. So with a CTE or a common table expression, what you can do, think of it kind of as a view inside a specific query. So up here, I'm going to say with my top 5 products as, and I'm going to put a big query inside there. And I can have 10, 20, 30 of these if I want. And basically build up small little building blocks, just like you typically would code on SQL. And then finally down here at the bottom, I can reference this later. So I can build up upon each other. And even within another CTE, so if I had one right after that, I could reference the top one. So you can gradually build on your joins, your queries, that kind of thing as you need to, and it actually results in something that's incredibly readable. All right, just a few more things. So Postgres has something called listen notify. It's essentially pub sub inside your database. It means you can actually use your database for a queue and it not fall over and just light on fire. It's a really awesome feature, and I believe there's actually a Celery backend for it now too. Per transaction synchronous replication. So Postgres by default, its replication is async. If there's certain transactions you really care about, you can turn this on at a per transaction level. So if you don't care about users uploading their photos, but you care about purchases, you can make sure that's synchronous. And maybe it takes a little bit longer, but you're not going to lose your data. And then select for update. So if you know you're going to query some data just to update it later, select for update's a nice thing, so you don't have to go back out and get the lock later. Essentially, this is the TLDR. It's got a lot of features in it. Transactional DDL is great, so that if you have a bad migration, you can roll it back and not leave your database in a bad state. Window functions, I said again, are awesome. Concurrent indexes are probably the default of what you want to be doing. But I think for me, like really the most exciting thing is the momentum around the project. 9.0, 9.1, 9.2 were all great. 9.3 is shaping up to be the same way. And it seems that each release is having more and more features in the release, really getting packed in. So I think it's got some solid momentum, and it'll continue to really get better with time. All right, and that's all, and I'll open it up for some questions.
Are there any questions? You will need the microphone for that.
You mentioned earlier full-text search. Does that also have support for n-gram analyze and that kind of stuff?
It has support for, I'm not sure n-gram. I know it has support for trigram. It has support for a lot of them that you would expect. It's a pretty rich full-text search, and it has support for different locales as well. I don't know specifically on n-gram, but I would suspect it's there.
But you would have to explicitly define the analyzer for the type of data you're indexing, or?
So there's some that'll come out stock with it. You can also create your own. The stock ones are pretty good. So I know people that do use it, kind of the stock analyzers pretty well. But I know people that are doing crazy things that are creating their own. So it really kind of depends on your use case.
Hi, great talk, by the way. You were talking about replication a little bit. Can you, out of your experience of running, I guess, a lot of Postgres databases, can you tell us a little bit about how to avoid a single point of failure in such a system? Because from my experience, that's a pretty tough one, and they're all somewhat flawed. So I don't know what's the most reliable in your opinion.
Yeah, so Postgres doesn't have multi-master today stock within Postgres. Right now, replication is asynchronous by default, and you can do synchronous replication, but it's not automated failover. There's a variety of things. So we actually wrote our own tool to help with synchronous replication called Wally, which ships the write-ahead log and helps with the base backups of Postgres. There's a variety of people actually using it and multiple maintainers now, so we've seen some pretty good adoption of it. But it's a really small, lightweight tool, which is kind of our philosophy for tools. There's Sloaney also for replication, though it's pretty hard to configure, manage, and use. I don't know of a lot of people using it, and I think people are trying to move away from it. Bucardo, I believe, is the best one today for true HA. Bucardo. It's pretty non-trivial to set up. I would, in the case of setting those up, I would hire one of the Postgres consultancy experts, like PG Experts or Second Quadrant or Command Prompt, essentially one of those three, just to make sure it's configured right the first time. And after that, it shouldn't be too bad to maintain and work with. But I know it's coming for multi-master as well as logical replication. It's hopeful for 9.4, but we'll see because it's still a little ways off.
So I guess then you guys use like Wall-E and some custom tools in
Yeah, we use Wall-E and a little bit of custom tools so that when you have to fail over, it's a little bit of a manual process. It's not fully automated today. So it's not truly HA, but you've got kind of a warm master already, which really reduces that time.
Great, thank you.
Yep.
You were mentioning a common table expression earlier on. Did you find that it somehow induces you to write such huge SQL queries that then they become kind of slow or cumbersome to perform?
Not necessarily. Like, I mean, long queries can be very fast and performant and small. I would rather have a readable query that's a little bit slower, than one that no one else can understand and know what's going on. And I think that's commonly the case when DBAs write queries. They write something that's perfectly optimized. Common table expressions sometimes will be not as perfect on the planner. Sometimes they'll be a little bit slower. But it's not orders of magnitude. It's 2x maybe in the worst case that I've seen. And I'm usually OK with that for readability as a trade-off.
Maybe misunderstanding something here. How does that work in comparison to views? Because I thought if you defined a view, then that would go into the query optimizer just as it was, and it would get optimized afresh every time.
So you can with a view, yes. A common table expression is done just when you run that query. It's not persisted afterwards. So it's actually not a view that's created. So there's a little bit of difference going on there. And you can do other things with them. So you can actually do recursive common table expressions, which things you can't do with a view. So there's a little bit of kind of back and forth going on there that the optimizer doesn't plan as well for as it could. I suspect it'll continue to get better, but it's just in my experiences. Sometimes I've seen the optimizer not be as perfect as it could be. And part of it's just the way you're structuring and building up a query on building blocks. And with probably more joins than you need to a lot of the time. All right, great. Thank you.
Thank you.